This is activity 3 from lesson 9, using side quotients to find side lengths of similar triangles. So these three triangles are all similar. So what that means is that the ratio of two sides within a triangle is equal to the ratio of those corresponding sides in the other two triangles. So if you're trying to figure out the length of a missing side, you can do this by using this idea that these ratios are equal. So, for similar triangles, the ratio of two sides of one triangle is always equal to the ratio of the corresponding sides of the second triangle. So the ratio of two sides of one triangle is always equal to the ratio of the corresponding sides of the similar triangle. So for example, the ratio of E to D, so E to D is the same as the ratio of 4 to 4, those are the corresponding sides. It's the same as the ratio of 12/5 to H, those are the corresponding sides. Now this one, the answer is, the ratio that gives you the answer is 4 to 4, that's equal to 1. So that means that E and D have to both be equal to each other, and H has to equal 12/5. That's how you can find the length of H. You can't find the length of E and D from this information yet, but you will be able to use it soon. So likewise, the ratio of D to 5. So this length here to 5, let me go back for just a second. This means that these triangles are isosceles triangles. So these lengths are equal. Two lengths that are equal means that it's an isosceles triangle. All right, so the ratio of D to 5, so D to this 5, is the same as 12/5 to 6/5. So 12/5 to 6/5 is the same as 4 to C. So this 4 to this C. Well, this gives you the answer here. 12/5 to 6/5, the ratio of 12 to something to 6 of something, no matter what those things are. In this case, they happen to be fifths, is 2 to 1. So there's twice as many fifths in 12/5 as there are in 6/5. So this ratio D to 5 also has to be 2 to 1. So if that's true, then D has to be 10 units long. And if that's true, that means that E also has to be 10 units long. I'll write this down in a few moments. So the ratio of 4 to 4 equals 1. Just got done telling you that means that these are isosceles triangles. All right, 12/5 to 6/5, that's a ratio of 12 to 6. That's a ratio of 2 to 1. So this longer side in the triangle is twice as long as the shorter side. Equal sides are twice as long as the shorter side. There you go. So the sides that are equal are twice as long as the shorter side. So 12/5 equals H equals 12/5. So these two sides are equal, so that has to equal 12/5. And I told you a moment ago that the longer side is twice as long as the shorter side. So if this side is 5 units, then this side has to be twice as long, or 10 units. This length has to be 10 units because these two lengths are equal. And if 12/5 is twice as long as, if 12/5 is twice as long as 6/5, that means that 6/5 is 1/2 the size of 12/5. So these are reciprocals. I'm going to multiply by 2 to go this way to get to 12/5. I can multiply by the reciprocal to go this way to get 6/5. And that helps me solve this last one right here of C. So 4 times 1/2 is equal to 2, which is the length of C. And notice that 4 is twice as long as 2, 10 is twice as long as 5, and 12 is twice as long as 6. So zoom on this just for a moment. So this relationship is that C is half the length of the long side, which is 4. So 4 times 1/2, or 1/2 of 4, is 2 units. Zoom in on the last one. These two lengths are equal, 10 units, and 5 times 2 is 10. 10, 1/2 of 10 is 5. So that solves that for all of the unknown lengths. So using side quotients to find side lengths of similar triangles. So looking at quotients of sides within a triangle to help you solve the lengths of sides of other triangles. Activity 3, Lesson 9.